My name is Pablo Guardiola. I'm working at Mapbox as a software engineer. And for those of you who are not familiar with what we do at Mapbox, we are a mapping platform for developers. So basically, what we do is offer a bunch of SDKs on top of location data. So that includes navigation, custom maps, and geocoding and many other services. But anyway, today I'm not here to speak about Mapbox because today we are going to learn how to build a DSL in Kotlin. Well, maybe not. Because actually what we are going to see is how to create a DSL using category. And what is category? Category is an open source library which written in Kotlin, which basically brings like the functional programming abstractions that you will expect from any other language, functional programming language, but in Kotlin. So basically, category is functional data types abstractions in Kotlin, over Kotlin. But let me ask you first a quick question. How many of you are implementing an application versus implementing an SDK or a library? Apps? SDKs or frameworks? Cool. I ask this because I want you to know that creating a DSL is not restricted for those of you who are like building, libraries or frameworks. You might need some time create a DSL for a specific, aspect of your application. So I hope that this presentation addresses all of you. So let's start with the key concepts. So what are the key concepts that I want you to bring by the end of the talk? So first of all, a DSL needs to be composable. So we need to define a DSL which you can compose primitive actions or operations both sequentially and in parallel. And you can think about this as a regular language like English. So imagine that you have words, and then you have a few words, and then you compose those few words, and you create like a whole understandable sentence. Another thing that it is key for this presentation is that a DSL, a well-designed DSL, needs to be extensible. So it allows us to add new operations and change the semantics of the existing ones in an easy way. And we will get into that, but the way of doing this is separating the concerns of every part and having like a decoupled DSL. So you can do, or you can change only on the place that you want to add a new operation or change an existing one. Of course, great DSL needs to be testable. So we need to offer a way of changing the runtime configuration. So basically, what we need is to offer different implementations for your different use cases. And finally, you will see that creating a DSL this way, using category, integrates really well, and it fits really well with your current framework. So imagine that you are right now using RX. This way of creating a DSL will allow you to still using your own models. So first of all, how many of you are familiar with what a DSL is or have implemented one before? Cool. Yeah. So as you may know, in this case, DSL stands for domain-specific language. And what we need to think about here is that we are creating a language. And we, as programmers, know that a language is composed by two parts. On one side, we have the syntax. And on the other side, we have the semantics. So, and what are the semantics? The semantics are what it does when you execute the model. So we can see a DSL as a wrapper over that model. So we are offering like an easier way to work with that language. First of all, to be all on the same page, let me quickly review the formal definition, and then you will see why I made this, like why I took the steps that I took to build the DSL. So a DSL is a computer programming language of limited expressiveness focused on a particular domain. Let's review each part of this definition. So first of all, we have in the definition the part of the programming language. And here we need to note the programming word, in the sense that a DSL is used by humans to instruct a computer to do something. So again, we don't want to create a regular language like English, for example. We want to create a concrete language which it is going to execute something in a computer. You know that we sometimes try to, to create a language which is really similar to actual language, and we normally fail because we try to make it quite general, and that's not the goal of creating a DSL. Then, second part, we have the language nature. This is also related with the key concept, with the composition key concept that I mentioned before. Basically, because if you have like instructions alone don't mean nothing, but when you are able to compose them, you are able to create a complex program. So this is like in a regular language. So you are able to create whole understandable sentences with just the small pieces, which are the words. Third, the limited expressiveness. You should use DSL for one particular aspect of a system. So it has to be limited. And this is also related with this last one part, which is that a DSL needs to be like focused. In order to, a DSL is only useful if it has a clear focus on a specific part of your system. So now that we are all on the same page and we know what DSL is, let's review how I wrote this DSL, and you will get the idea, and you will be able to create your own DSL following the same steps. So this is UIA gesture gen, and basically it is an open source DSL, which basically allows you to automate gestures on Android, but using this DSL. And I use UI Automator, and for those of you who are familiar with UI Automator, it's not that friendly. So I thought that it would be great to create, a DSL on top of UI Automator to create like gestures like rotate a view or make a zoom in a view, because when we had to do a performance test of our SDKs, and we didn't have a way of generating the the gestures on our maps. So, and at that time I was starting contributing in category, and I thought that it would be great to see an example of a category, like a real example doing something, because when if you are not familiar with functional programming, it could like seem that it is like something that it is really hard, because normally functional programming is related with academics and research. So it's okay, no worries. But yeah, so I thought that it would be great that to show you how you can use a category in a real example. And I'm not an expert in functional programming, so what I want to show you is that you can also create this kind of DSLs using category, and it's not that difficult, and you eventually get more familiar with the approach and the paradigm, and but yeah. So first of all, let me go like to the end of the talk, and we are going to review the usage or unusage of the DSL. So then you will get the idea on how I implement it. So here we have a function which basically is using is taking in a parameter and which is the element. And for those of you who are not familiar with UI Automator, basically the UI object is a view. So we are then composing a series of actions, and in this case we have pinch out, swipe down, and then what we are doing is, okay, because all of these actions will be executed sequentially, we then validate that all of them were correct, and we are doing that using this like syntactic sugar API, which will tell us that every action was correct, and then you can get this when you execute this, the function, you get this. So as I told you, we were using this for like testing the performance of our SDKs. So imagine that we change the implementation of something on the maps, and then we want to see if it's still it is performant as was before. But as you can imagine, this is not the only use case in which you can use this. Imagine that you want to automate the flows of your application. Let's say that if you click here and then you click there and then swipe here, and then you want to check that everything was correct. So it could be useful also for testing purposes. And how I did implement this? Using the free abstraction from category, and basically what free means is separating the concerns using an abstract syntax tree, and then executing this abstract syntax tree using an interpreter. So maybe you know that there's no like a concrete implementation of the GAN of 4 design patterns, but here when you start learning more about functional programming, what functional programming offers you is that it is not that focused on how you are going to build your program or whatever. It is more like, what do you want to build? So in this case, we get this like canonical or unique implementation of free, and we will get that for free because it's already implemented in category. So, but yeah, this is not, as I told you, using category is not restricted of taking advantage of the language features or whatever. So let me explain you how are the steps that you need to follow if you want to create a DSL this way. First of all, we need to define the algebra, and the algebra means the operations that you want to include in your DSL. And here, in my example, we are modeling this as a SIL class because we want close inheritance. And then we need to, add all the operations that we want to support in our DSL. And if you have done a DSL before, and if you have done it in Kotlin, like you need to take into account that how you need to translate this into the free abstraction. So right now, when you were writing a function, now you will write a class or an object, and the name of the function now will become the name of the object or the class, like this. And then the parameters that you were passing into the function now are the parameters of the objects. And finally, the return type, it is now the generic type. And then you will add the operations that you want to support. And if you want to use like more advanced usage of free, in this case, you will need to add this instance. And this will give you like the functional programming operators that you will expect in many other languages like map, fold, flatten, and all of these operators. But this is not something that it is necessary in the vast majority of the cases. And then we need to lift everything to the context of free. And this is basically what we need to do is to create the objects. Somehow we need to instantiate the objects of all of our operations. And we do it like this. And what we are doing right now is we are reifying the operations in memory. So this is really great because it will give you for free an stack safe program. I know that in Android we don't normally see Stack Overflow exceptions, but it is great to take this into account. And then you will do the same for every operation or every action. And as you can see here, this code is like boilerplate. All of the code is the same. So because of that, right now in category, we are working on a library which will generate this code for you. Third step that you need to take into account to create a DSL using the free abstractor is that you need to provide the semantics with the interpreter. This is basically you need to give the implementations of your actions. And as you can see here, because we model the algebra using a SIL class, you will need to provide every action within the when. And what we are doing here is creating an interpreter which basically will execute every action that you define in your program, no matter if it fails or if it doesn't fail. And then we are like collecting the results in a list. So then you will be able to know what actions or what gestures fail. But again, this is not restricted to this interpreter or this use case, because you can also create a new interpreter. And in this case, I added the login capability, and then I also use another interpreter, which it is like kind of a fail-fast approach. So whenever you reach into an action which fails, it will stop the execution of the following ones. And as you can see here, we don't need to change anything else but the interpreter. The algebra, you don't need to touch it at all. This is like, imagine that the what is the algebra and the how is the interpreter. So when you want to like offer a new behavior of your DSL, you only need to change or create a new interpreter. And finally, as I told you, we have the algebra, which is an abstract syntax tree, and then we have an interpreter. And the only thing missing is how we, traverse this tree and get like the results. So this is like the last step that you need to take, which is we want to unfold the abstract instance tree, and then we are validating here that, as I told you, using this interpreter, if it is going to execute every action, and then will return the error in a list, or it will return an empty list. So that will mean that everything was correct. But here, anyone doesn't stop you to, instead of use this validated non-empty list, maybe you are working with Rx and you want to, offer or return an observable. So again, using category is not about, like you will need to get rid of your all current code, or all your tools, or the ways that you do the things. It is more like we offer you like a whole, and then you only need to pass in your data. And then when we reach this point, we could take advantage of many other features of the language, which in this case I created an API called has completed correctly, and we are doing this using an extension function from Kotlin. So what I'm trying to say is that when you have your whole DSL, then you can add syntactic sugar and create APIs that could be useful for your users. This is a way of returning the list of the errors that happen, because as I told you, we are in one interpreter we are returning a validated non-empty list. So then you could be interested in knowing what actions fail. Again, for example, you know that you are able to overload the some operators in Kotlin. So in order to make this DSL more functional, functionalist, I overloaded the plus operator, and now you can compose also the actions using the plus operator. And this is another example in which right now I'm using the fail fast approach that I told you. And this means that if any of these actions fails, the following ones won't be executed. And you can get something like this. So just to sum up and recap a little bit, what are the takeaways that you need to bring with you? First of all, you need to take into account that we need to offer a way of composing actions. Again, this is like you have a small or primitive operations, and then you will be able to compose more complex programs. A DSL needs to be extensible in the sense that we need a way of adding new operations and creating or change the existing ones in a easy manner. And then we should support also the reusable DSL in the sense that the DSL needs to be reusable, and this is using different interpreters. And again, you don't need to think about the algebra or how or what it is doing. It is more like if you want to offer a new implementation or a new behavior, you will do that, creating new interpreters. And also using category and using this approach, you won't have any problem if you are using any other frameworks within your application. And then also because of Kotlin and the check compile time, this is really good. And when creating the DSL, I would say that it is less prone to errors because you know your errors. And in the functional programming community, we have like a saying which basically says that if it compiles, is it gonna work? So it is like it's quite refreshing that when you have every piece into its place, then it works. It is like magic. And of course, as I told you, I'm not an expert in functional programming, but I think that that would be a great way of showing you how to start, using this paradigm. And of course, I encourage you to take a look at the repo code, which is open source. And if you are more interested in category, you can always open a ticket saying hello, and let's say that you want to start contributing. We have also a Jitter chat, so go and check it. And I want to remind you that we have Raul Raja submitted a KIP to try to integrate a category into the language, into Kotlin. So if you are interested, go and support it because it's really cool. And that should be all. Thank you.